All right, so let's talk about something that some of you might have noticed. We have a problem which is not obvious, okay, with lerping, and that's if I'm going to lerp angles. Lerping angles has a gotcha, and here it is. Maybe I should say this first. It's very tricky for rotation. And the reason is because our idea of going between angle A and angle B isn't what we do in math, okay? If I go from angle of 10 degrees to 350 degrees, you don't go 10 all the way from 350. Most people think that you go along the acute angle. So when we're doing it for rotation, we need to make sure that we lerp the acute angle. So I'm going to draw out a coordinate system. So imagine that you have this is my angle 0, okay? And I have a vector A, or an angle A, and I have an angle B, okay? If I'm going to lerp that, most people would think it would go this way. A would come down to B. But if I just use lerp as I've explained it, A goes to B, it's going to go the long way around because it's not going to go negative. Okay, it's just going to take that number. So it's really simple to fix this. It's tricky to get your head around. But if we assume that B is bigger than A, so if it's not, just flip them basically. You work on the other one. So if B is bigger than A, then you take if B minus A, the difference between the two, is bigger than pi, okay, then we have an obtuse angle. Like in the picture shown. If I take B minus A, because pi would be right here, right? That's pi. So it's bigger than pi. All right, so all that we do is we take B and we minus equals 2 pi from it. Which is kind of funny. If I take away 2 pi from an angle, okay, subtract, it comes all the way back. What's the big deal? The difference is, instead of having this big positive angle, we're converting B into a negative angle, okay? This is negative theta. So what you've done is you've taken B from this big positive angle to a negative one. Now if we lerp them, it's going to go, A is going to shrink towards the B instead of going all the way around. So this is a little trick if you can code it up. I will note this is the kind of thing that can get really, really tricky if you don't really think it through, okay? But this is how it works. Let me just open up a demo for you here. I should write that out. Demo 5. Okay. So I'm going to build on the demo we saw before, where we have A and we have B and we interpolate between them. What's different here is I added in a theta. So X, Y, theta. So let's take a look at this. We've added in a theta, so it's actually going to interpolate the angle as well. So here's the same code as before. It's flying around. If I click, it'll slow down. Now I've also added these, you can see to my debug visualizer, I've added the angle so you can see the start angle and the end angle. Just like that. Bam. Cool, right? So you can see it's interpolating the angle as well. So all I've done to my code was we add the angle to our definition of the object. Everything else stays the same, except we also interpolate theta. Right? We don't just interpolate X and Y using lerp. We lerp theta as well, except I have this my lerp acute angle corrected function to do that. And then here's all of our debugging code that we've already talked about, and I added in those angles so you can see it. But here's my lerp. Nothing has changed. But here's my lerp acute angle. All I did was I calculate. Wait a second. I'm assuming B is bigger than A. So if B is smaller than A, I'll make a small change. I calculate the difference between the two. If the difference is bigger than pi, this absolute value is in case they're backwards and A is bigger. That's all that is. If it's bigger than pi, I have an obtuse angle. That's not good. So then I take B and take 2 pi out of it. If A is bigger than B, then I make A the minus 1. It doesn't really matter. Okay, so I do that, and then I run lerp on my adjusted A and B. Now you might be thinking, Jim, you're doing that every frame? That's a lot of math for every frame. Yeah, if you wanted to optimize this, you could pre-compute your angles and make sure that you send it in correctly. But for for simplicity's sake and for purpose of illustration, I don't think it's worth it. So this is all we're doing. We're doing this little adjustment, and then we're going to call Lerp from angle A and B, and it'll do the acute angle. If it's obtuse to start with, you take 2 pi out, now you have a negative angle, it'll Lerp in the right direction. Nothing else has changed. Okay, except that it'll give us a random angle when I click somewhere. That's all. So here we go. Click. So you can see it's lerping between those 2 angles. Let's see if I can find an obtuse one. Yeah, let's see, how would that... Well, it depends what 0 is. I guess it depends what 0 is in this coordinate system. 0 would be to the right, I believe. There we go. Like, it's doing nicely. So they're all going to the left. It can be tricky to get your head around, and the way I do it is you bring the one angle up to the other one as if they're the same, and in this case you can still see it's going in the acute direction. There we go. There we go, right? It's interpolating this way. Instead of going all the way around, it's interpolating that way, which is quite nice. Cool. So you can spend some time playing with this. This is lerping my angle in the acute fashion and not the obtuse fashion. That's kind of fun. This one looks tricky because it's almost completely 180, so no matter what you do, it has a spin, you know, the whole way around. So cool. So that's how you lerp angles. You have to be a little careful to make sure you know what you're doing with the acute. Versus the obtuse, and it can get a little tricky. You know, this demo makes me insecure. I feel like, is there a case that I missed? Is there something I'm missing here? But this looks pretty solid to me. All right, I'll end that there, and we'll come back and learn about keyframes.